Welcome after the 10-minute break to Next Level with Redis with Spring. My name is Christoph Strobl. I work for the Spring data team, mainly on Redis, MongoDB, and Solr. I sometimes do a little bit of JPA and also contribute to the Commons module. So what is Redis actually? Redis is a little piece of software that was invented by Salvatore Sanfilippo in Sicily, somewhere in Italy, basically out of a need. And he named it because he had the need for a remote directory server. So what is Redis actually? It's mainly used for, it's a key value store. And as such a key value store, it's basically used for caching, it's used for queues, some people use it for distributed locking. It's used as a distributed session store, some people use it for analytics using the bitfield operation. And with the recent release 3.2, we also got geospatial support with the geo-indexes. To do all this, Redis has different data structures internally. So not only a key and the value, but rather it has strings, it has lists, it has sets, hashes. It has something called C-sets, which are sorted sets. It has a structure called hyperlog, which is extremely fast at counting unique things. If you want to count, let's say, unique visitors to your website, then hyperlog would be the data structure to go with. And on top of all those data structures, it offers some pub/sub, publish subscribe mechanism. It has support for scripting using Lua script, and let's call it support for transactions. Well, yeah, let's call them transactions in the way Redis defines them. What we're gonna do in the next 30 minutes or so is we're gonna have a look at the at some basic Redis commands so that you all get an impression of what Redis can do. By the way, who uses Redis here and is familiar with it? Oh, quite a lot of people, not all. Don't worry, it won't take too long, the introduction. Then we'll have a look at the Redis cluster and Redis cluster support within Spring Data, object hash mapping, strategy, secondary indexes, and all that stuff. That fits into 30 minutes. Okay, let's start off with a simple introduction to Redis data types and commands. As I already told, there is something called strings. Those are basically the key value pairs, so you have a key and the value. Then you can set, so you can set a key and the value. You can get it, of course, using get command. You can get the value and set a new one and get the old one back using getSet. You can set a value if it didn't exist. You can ask for the string, length of a string. You can append stuff to a string that you already have stored. You can get just the bits out of the string you have. Or if your string happens to be a number, you can also go on and call increase it by a certain value or increase it by a float value, however you want to. And of course, you can decrease it the same way. But this just works if your string or the value happens to be a number. Redis also supports the list data type, so you basically have a key and a certain list of values. Again, you can push to it on the left side. You can remove stuff from the left side. Same for the right. You can ask how many items do I actually have within the list. You can set a certain item on an index. You can get it. Of course, you can insert it at a certain position. You can get ranges out of there, so multiple items starting from 2. And you can remove a number of items from either the left or the right, depending on which side you choose. We got sets, which are pretty similar to the data types that we have in Java, as most of us are Java developers, I guess. So with sets, you can basically add stuff. You can remove stuff from the set, get stuff out of it. You can ask if a certain item is a member of a set. You can remove stuff from the set. Maybe if someone dies or so in this case. You can ask how many items are in there with the card request. Yeah, and we had that already. We got hashes, pretty similar to the ones we have in Java, despite the fact that the hashes are nested behind the key itself. So you can set values, you can get single values, you can set multiple values at once if you want to. You can get them back multiple. You can ask how many values do I actually have within the hash. You can remove stuff. You can ask for the keys, the values, and of course both of them get me all the keys and all the values at once. And now the interesting stuff for the so-called transactions. You basically issue a command that calls multi, which sets up a queue for this particular connection you're using to talk to with Redis. And when you now call set for a key with a certain value, it just gets queued. And then you ask for the key using the get command. You just, okay, it's queued. You won't get any result back as soon as you call exec, which basically then takes all the queued values and just executes all the commands in a row within a single transaction, more or less. And then it gives you a list of the results back. So you just would get OK for the set command and then the value back for the get command. If you call this card, it's just gone and you can start over again. So much to the introduction. Now let's move on to some more interesting stuff like how do we actually run Redis? So basically you go to the redis.io website, download it and call a makefile on your computer and then start it up. Then you get something like this, which is a single Redis instance. And pretty simple, wrong window, you just basically start it up. Redis is running pretty fast. You go to the command line, call something called the Redis CLI and are good to go to interact with Redis. And so you can say set key 1, spring, set key 2, 1. And then you can go on and call mget key 1, key 2, and you're done. Pretty easy. Okay, so far to the single Redis instance. Of course, the problem with single instances is once they go down, you're pretty much doomed, because what happens to your data and to your application who depends on the data stored in Redis. So what you potentially could do is you could add slaves to your master node, just like there, and then just read from the slaves until your master comes up again because you restarted it, hopefully. That's one way to do it. A more reliable way is something called the sentinels that have been introduced in Redis for quite a while. This was way before we had a Redis cluster that came with the 3.0 release. Sentinel we had a lot of time before, which basically you set up a set of additional servers that go on and monitor your master and slave nodes. And those sentinels basically detect once a master goes down. And depending on your settings, they agree on, oh, the master isn't reachable from, let's say, Sentinel 1 and Sentinel 2. So two nodes agree on that the master is down and they go on and elect a new master and potentially pick one of the two slaves and say promote it to master again. And once the old master is up and running again, the data gets synced back again and the original master is set back into place as a slave now. But your application keeps up and running, hopefully, despite maybe a little timeout of a few seconds, depending on your configuration, how long it takes for the sentinels to recognize the server is down and, yada, yada, yada. Okay, that's been there for quite a while. And with this single node, you have access to all the commands and that stuff. But how does Redis cluster now work? Redis cluster was introduced in Redis 3.2. And basically, it doesn't have any sentinels anymore. So basically, all cluster nodes talk to each other all the time. So they know about each other. There is no dedicated monitoring facility there, but rather the cluster maintains its state itself. So let's assume this is a cluster of two masters. Each master has two slaves, so they all communicate with each other. And the thing I want to note about is that once you set up a cluster, the cluster will have auto-sharding of all your keys, which means once you add a key to Redis, it basically calculates some value, which is a slot from the key, and distributes it to the node that holds that particular slot. So your data will automatically be distributed across all those nodes, and you have 16,484 slots available. Of course, you can pin your keys to certain slots to make sure you know where they land, or you calculate it yourself. But that's one thing you have to be aware of. So let's just spin up a cluster and see how that works. Let me just stop that process over here. And with Redis 3, you get, fortunately, a utility shipped with it that's called create cluster, which is a little script that allows you to set up a cluster real fast. So all you have to do is basically create a cluster, you start the cluster, and then you go on and create the cluster. So this will set up the cluster configuration. It will create a cluster of 6 right now, which will be 3 masters with a slave each. And you have to agree on the cluster configuration, so it basically divides those 16,000 what have you slots according to all the nodes. Then all these slots are assigned, and you can go on and start up the Redis CLI with the additional -c flag for a cluster, so that Redis CLI knows that you're in cluster environment, and the port that you want to connect to. And then you just go on and set the key. Let's call it Spring again and set key 2. Set key 2 and let's call it 1. And what you see here down below is that you got redirected by Redis itself. So basically what we tried to do is we connected to the server at port 30,001. But the slot value for key 2 was actually 12,422, which was located on another node. So Redis returned an error said that basically tells you that that particular node you sent the request to doesn't serve actually that slot, and Redis CLI is so intelligent to just extract the information and redirect you to the actual node you have to send your request to. But that is something you have to be aware of when dealing with the Redis cluster and the clients directly, because obviously your data gets automatically sharded. And of course you could then go on and say get me key 1, which works perfectly fine. But when I issue now mget, as I did before in the, let's call it key 1, key 2, in the single node environment, maybe I should take key 2, then you receive an error. And this is because Redis doesn't serve you cross-slot requests. So basically it can only return you data if all the keys within the command you execute match the same slot. Otherwise it will just fail. And the same is true for the Redis clients in Java that are currently out there, because they emulate basically the behavior of Redis CLI. So once you're using plain Redis, it will just go on and give you a cross-slot error if you try to use a multi-get within a cluster environment. And that's exactly where Spring Data comes into play. Because we can help you deal with that, because we make it really easy for you to deal with the cluster. So we got cluster support built in there, and we make sure that we calculate upfront the slots that your commands are issued to, and then asynchronously connect to all those nodes that are involved, collect the values there, aggregate them, and give them back to you once we were done. So basically what I could do is I could go on and collect all keys in the cluster, or, yeah. As the keys command is another example. So basically if you go on and ask Redis on the CLI level, give me all keys, it will just give you the keys on that particular node you'll send the request to. Doing the same thing in Spring Data Redis makes it transparent, because we just go on and fetch all keys, combine them, and then return them to you, no matter where they are actually located. Of course, we offer you via the Redis connection, which is the main abstraction for interacting with Redis. We offer you the opportunity to just go to a particular Redis node and ask that one node how many keys it has. So you're free to choose and just connect to a single node, but by default, we'll just do our best to make it transparent, so it feels like as if you're interacting with a single node instead of a cluster. So we take the pain more or less away from you. We even can execute those cross-lot commands, as I told you before. So this would be basically the mget command, and I can show you this basically also works within the cluster I just set up. Okay. Since our world isn't as flat as keys and values normally, but rather consists of complex objects like a person we have here with different properties, let's say ID, first name, last name, and an additional complex object like an address, it's sometimes you need to map those into Redis. So the most simplest way to do it, to add data into Redis, complex data, is just go on and make it a JSON string. Feasible, easy, use JSON, use Jackson, whatever, just call set and give it a key and then pass it on the JSON string. The problem is all you can do with the JSON string is you can get it. So if you're potentially just interested in, let's say, first name and last name of your data stored in Redis, with this approach you have to fetch all the data back, run it through Jackson again, and then get the result out of it. Or you can update a property within there. Let's say you got a typo in snow because it should be capital case S. You would have to replace the entire key with the value. And this is what where object hash mapping can basically help you, because it flattens out your complex objects into a Redis hash. And this could potentially look like this. So you'd call mset for multiple set into a hash, give it, let's say, a key for the class you're storing in there, and then just flat out the properties into the key and values of the hash. And this would allow you to basically, just as on the other side, fetch all the items, just use hgetAll, and you'll get all the properties back. But you could also decide to just get a slice of your data. Just get me the ID and the last name. That's possible now. You can also ask if some value exists, some property exists in there. And you can set update basically those properties without having to reset the entire entity, which is quite nice and helpful when JSON rendering isn't enough for you.
So those H commands?
Yeah.
Are those Redis commands?
Those are all Redis commands. So it's basically H stands for hash, and then you call M for multiple and set. So Salvatore tries to shorten all the commands a little bit. But yes, those are Redis commands. It's just used for mapping potentially, because you might have an interface stored in there, and it's pretty hard to map an interface back. So you maybe want to store the actual class instead of an interface inside. It's just one way to go. Okay, so let me show you this real quick. Whoops. There's basically the OHM mapping. And this is what it would look like. So you basically can go on, set up a mapper, which is an object to hash mapper that you can auto-wire. So you basically can just register a bean. We have something called an object hash mapper that uses a domain meta model behind the scenes to just detect, hey, is this a list, is it an interface, what type is it, to render all that stuff. And then you can go on and use that stuff in there, and you say just mapper to hash, give it whatever entity you have. I printed it out here, and then you just say HMSet, give it a key, and then just put in the map of values that you have. And to read it back, you basically go on, get the connection, call hgetAll with the key, run it through the mapper, and then you'll hopefully get the result you expected. And if you have a look down here, that's basically what such a hash looks like when you run through the mapper from Spring Data Redis. So we have the class type here that tells you which class you mapped. The dot notation tells you that this is a nested property. This also works for lists, maps, and what have you. So lists will be indexed with 1, 2, according to the order that you have in there, and so on. Great.
So the key, so you started with a JSON,
Yes.
and you populated, you put it into Redis as a hash.
I could use, I don't need to use JSON. I could use JSON if I wanted to, piping it through a Jackson mapper. We have those mappers in place in Spring Data Redis as well. But we also have the object hash mapper as an alternative if you want to store the stuff in a hash and have all the opportunities to modify your data using the H commands.
Okay.
How deep does your object hash mapper go in terms of complex? Does it go up the address and then?
The question was, how deep does the object hash mapper go? It takes your entire domain model, what have you in there, as long as there is data in, it just goes on and maps it. And if there is a type it doesn't know, it will infer. So if you have a list of interfaces in there, and it will infer the concrete classes, as we saw with the underscore class, so you can remap it back. Okay, so let's have a quick look onto secondary indexes before we dive into repositories. So what secondary indexes are is basically when you have those complex objects, it allows you to add a helper data structure, maintain helper data structure to find keys basically in a certain way. So basically you could imagine you wanted to find people by their first name. So you could build up a set holding all the keys. So the key of the set would basically be the property path plus the value. So you would go for person's first name, and all the persons with John would, their key would be added to a set, which would basically look like this. So you have a set for all persons named John, and we'd add that particular key to it. We could do the same for, let's say, a last name. And now you see we got those two sets overlapping. And we can make use of this overlap by issuing an sinter command, which is a Redis command that intersects two sets for, let's say, finding all people that are called Jon Snow. So it would return me just the 1, 2, 3, and I would basically have a finder defined. I could go on and call sUnion to unify both sets, and this will give me basically all persons named John or Snow. So I can get the keys back and then load the values. So this is basically what secondary indexes are for. You can use those with C sets as well to order them. There, you could also use the geo commands that were introduced in Redis 3.2 to build up geo-near indexes and so that you can, let's say you have a list of stores, you can query for stores within a certain area. That would be possible just by adding a secondary index. And that's what they for. There is a great article on redis.io that deals with secondary indexes. I would recommend checking it out. It's worth reading. Okay, with Spring Data Redis, what we offer you is basically you can have annotations to help you setting up and maintaining all those indexes. Because when you, let's say, save, call a Redis repository method that allows you to save entities, we go on and call the hset commands because we run through the object hash mapper, and then we maintain the secondary indexes for you according to the @index annotation within your domain type. So we'll go on and just set up the index for you. For updates, of course, you have to think about the indexes that you have within Redis, your secondary indexes. Because if you have a typo in Jon Snow and update the value for the first name, you have to make sure your secondary index gets updated as well. So you have to remove basically the key from the already created index and reset it to the new stuff. So first, of course, you have to set the value into the hash, then you remove the key and add it to a new set. This is what we take care of for you when you're going through the Redis repositories. And of course, with Spring Data Redis, since the latest Hopper release, we give you the opportunity to make use of the derived finder methods, which allows you to just define a find by first name and last name method, which will go on, check the indexes down there, and then just, when you call it, issue an sinter command, and then just fetch the keys one by one using hgetAll. So that's how it works. I don't think we have that much time for the demo, so you have to basically trust me. No, we have time. Let's go in here. Would be boring unless. Okay, so what we got here is basically a list of the family Stark, starting with Eddard, Robb, Sansa, Arya, Bran, what have you, all the guys that are in Game of Thrones. And you could go on. We have the repository here. We have a method called flushed history users that just saves the Stark family. We got the repo that find by last name. So we take Eddard and hopefully we get all, despite Jon Snow, because he has a different last name. Actually, works pretty fine. So here's no cheating. This is just the repository find by last name. We can combine it by find by last name. And so let's search for Arya. Arya first name, Arya last name. Finds just Arya, leaves all the other Starks out of our way. What we also can do is just update the entity. So here's basically the example. We set Jon to John, flush it, and then don't find Jon. Then we updated it and make sure that all the sets are maintained correctly. Thank God it worked. We got additional support since Redis allows you to expire domain objects automatically. So we got support for that, wire and annotation. Where is it? There is, we have the time to live annotation, so you can put it on a property within your domain type. And let's say we set it to 1 second, and then Redis will just expire the entire hash that holds that value. We make sure that we also remove the according helper structures and all that stuff. And one special thing about it is that we also receive the expired events that are sent out by Redis. And what we do up here is basically we registered an application event listener that listens to the Redis key expiration event for a person namespace. And once we receive the event, we don't only get the key that expired, but also the hash values that have been expired. This is different to what Redis normally does, because Redis normally tells you only the key that it expired, but we maintain a phantom key and all that stuff, so we can provide you with the original value that expired in here. Cool. So real quick, we also allow you to use references, so you can store stuff in different hashes. The expire command I showed you. You can register custom conversions just as you would do with MongoDB. You can have spell-based indexing depending on whatever stuff you like. What's next for this module? Geo-indexes, pretty nice. So for the address, you can just add an additional annotation, add geo-indexed, and we'll make sure that we set up the according geo structures for you and that you can issue just the near queries. We just call it georadius and hgetAll. And of course, reactive programming. This is a draft currently we're working on. We're shaping the API. But for Spring Data Redis 2.0, we're eager to provide you with an reactive API for Redis. And just some related sessions, Cassandra, tomorrow on Thursday, Gemfire and Hazelcast. So thanks for your attention. I finished just in time. If you have questions, just come to me right after. Thank you.